Today we are going to solve two problems, that is problem 3.11 and problem 3.12. The problem 3.11 is find the momentum space wave function pi of p and t for the particle in the ground state of harmonic oscillator. Then what is the probability to two significant digits that a measurement of P on a particle in this state would yield the value outside the classic range for the same energy. This is outside the classical limit that we have to remember. So then we know the ground state wave function for harmonic oscillator is psi naught psi sub 0, which is equal to m omega over pi h cross whole power 1 over 4 multiplied by e minus m omega over 2h cross x squared. The momentum space wave function is given by the Fourier transform, that is psi sub 0 of p is equal to 1 over square root 2 pi h cross integral between minus infinite to plus infinite the wave function psi naught, which I have shown in the yellow color, psi sub 0 x e power minus I kx dx. Now we will solve this problem. So we have seen psi sub 0 of p is equal to 1 over square root of 2 pi h cross integral between minus infinite to plus infinite psi sub 0 of x e power minus I kx dx. Now you replace the psi sub 0 x. So we know the ground state wave function, which I have shown in the yellow color. So m omega over pi h cross whole power 1 over 3, then e power minus m omega over 2 h cross x squared. Then here p, I can change the p as p over h cross. That is uh, k is equal to p over h cross. So we know that this is from de Broglie hypothesis. So E minus I P over H cross, I have changed to K multiplied by X Tx. Now what I am going to do is, here I am going to do small tricks. That is, I am going to make this m omega over 2h cross, this one m omega over 2 h cross as a, this is a, and is equal to a, and I am going to make p as uh, p as minus I p over h cross. So this is p. So I can rewrite this exponential term inside the integral as sorry, p is equal to I p over h cross. So here also I will change, I will make a correction. So this is I over p h cross, except this minus sign. So I can rewrite this exponential term e power minus a x squared plus px. Now we have to integrate this. This is the standard integral for which the value is square root to pi by e power p squared over 4a. Remaining thing I am keeping as it is. So here a we know m omega over 2 pi, m omega over 2 pi. Sorry, m omega over 2h, m omega over 2h. 2h I brought it to the numerator. Similarly, this one, p, p is this one. I squared is minus 1, I squared p squared uh, over 2m m h cross omega. This I will rewrite this. What is p squared over 4a? What is p squared over 4a? P squared, we know this is p squared is I squared is minus 1 p squared over h cross squared divided by 1 over 4a, 1 over 4. So 1 over 4 a. What is a? A is m omega over 2h cross. M omega over 2h cross. Here this 2 will get cancelled with this 4, which will become 2, and this h cross will get cancelled with this h cross square. Now you will get in the numerator minus p squared, and in the denominator you will get 2 uh, this 2 m omega over m omega h cross. So minus p squared over 2 m omega h cross. That is the momentum based wave function. Here you have momentum instead of position. Of course you have all other constant. Now we will try to simplify this. So now we got this expression. Here we can cancel some of the parameter, that is square root of 2 pi h cross. Here also in the numerator you have square root of 2 pi h cross. Then you have this term left, square root of m omega 1 over m omega, square root of 1 over m omega. You bring this m omega inside this bracket. So if you bring this here 1 over 4, so naturally power 1 over 4, so this will become m squared omega squared. So you can cancel this m omega and with this m squared omega squared, which will become just m omega. So now the wave function is psi sub 0 of p is equal to 1 over, here you have m omega pi h cross, of course pi h cross m omega 1 over 4 e power minus p squared 2m h cross omega. This is a normalized Gaussian in momentum space. So we will move further. We know the classical total energy in ground state is E is equal to half h cross omega. Yeah, also we know in classical mechanics E is equal to p squared over 2m. So if you bring this 2m to the other side, then p squared is 2mg. Then if you take square root, p is equal to plus or minus square root of 2mg. Uh, but 2mg, what is E? E is equal to half h cross omega. Then this 2 will get cancelled. You will get 2mg is equal to m h cross omega plus or minus square root of m h cross omega. So the classical range of momentum is p is equal to or less than square root of m h cross omega, because this is the classical limit. We know that this momentum based wave function is equal to 1 over pi h cross m omega whole power 1 over 4 e power minus p squared over 2m h cross omega. So the probability outside the classical range is, that is capital P indicate probability, which is in the range modulus p is greater than, because if it is less than square root of m h cross omega, then it is in the classical range. If it is greater than this, it is outside the classical range. So which is equal to minus infinite to integral minus infinite to plus infinite. This square of this wave function, momentum phase wave function. We are integrating with respect to momentum. So we can replace this momentum phase wave function, that is 1 over, which I have shown here, 1 over pi h cross m omega power half, because we are taking modulus square, then e power minus p squared over m h cross omega dp. That is, here 2 will go away because we are squaring it. And limit is I am taking in the positive x-axis, square root of m h cross omega to infinite. So we will solve this integration. So we got this expression for probability. Now you can take this argument in the exponential term as z squared. It's a dimensional quantity. So if you take z squared, the argument of exponential, then z is equal to p over square root of m h cross omega. So if you differentiate this, you will get tz is equal to 1 over square root of m h cross omega t p. So you are differentiating with respect to p. Then TP, you take this to the other side. So TP will become square root of m h cross omega tz. Now you can see this when you are replacing TP by this, you replace TP by this. So this square root of m omega h cross will get cancelled with this m h cross omega. So you will get one outside 1 over square root of 1 over pi. So square root of 1 over pi and e power minus z square dz. So we are representing with respect to z. I have introduced 2 because the symmetry, we have equal probability both right hand side as well as left hand side. So this is right hand side. Similarly, you will have same probability along the left hand side. That is the positive x direction as well as in the negative x direction outside the classical limit. Because of the symmetry, you will get same probability. So I am multiplying this by 2. So this value of this integral, including this multiplication factor 2, is equal to error function 1, for which the value is 0.16. So we have solved the problem 3.11. Then we will move on to problem 3.12. Now we will solve the problem 3.12. The problem 3.12 is find pi of p and t for the free particle in terms of the function pi of k introduced in the equation 2.101. So that for free particle, the modulus square of pi is independent of time. So first, take the wave function psi of x and t is equal to, in terms of pi of k, is 1 over square root of 2 pi, a integral between minus infinite to plus infinite phi of k e power I kx minus omega t tk. Now, if you take time as initial wave function, psi of x and 0 is equal to 1 over square root of 2 pi integral between minus infinite to plus infinite pi of k e power I kx tk. So, because t is equal to 0. So, for a free particle, the dispersion relation is omega is equal to h cross k squared over 2m. With this, we will move further. Since P is equal to h cross k and psi of k is the amplitude in k space defined, the psi of P and T is equal to pi of k e power minus omega k t. Here pi of k is amplitude. So we replace k by P over h cross. Here also, the dispersion, the H cross omega k energy is equal to P squared over 2m. Then you bring this H cross to the other side. So this will become H cross. So we can rewrite this as e power minus I P squared over 2m H cross t. Now you take modulus square of this. So modulus square of psi is equal to modulus square of pi and modulus square of this exponential term. If you take modulus square of this exponential term, you will get this as 1. So the modulus square of psi of p and t whole squared is equal to uh, pi of modulus square of pi of p over h cross. So which is a function of k. So naturally here if you see the right hand side, there is no time dependent. Time dependent will go away here. So we have proved that the probability is independent of time. Thank you very much for watching my video and supporting me continuously. Thank you very much.